Yo, what's up YouTube? It's Kiwi the Cat with a new video all about quadratic equations. Today, we're going to review what a quadratic is, how to find solutions for them, and how to go between their different forms. A quadratic is a type of function where a highest degree is 2. All quadratics take this basic U shape, and depending on our equation, this U can be wider, thinner, or even upside down. So what's a quadratic's basic form, and what does it tell us? The basic form for a quadratic is ax squared plus bx plus c is equal to 0. This equation is more commonly called standard form, where a tells us if our graph opens up or down, and c tells us our y-intercept. If a opens up, we'll have a minimum, and if a opens down, we'll have a maximum. The difference between a minimum and a maximum is the location of our vertex. To identify the vertex, we need to see where a line changes direction. An example would be this graph. Right here, you can see as the y's become smaller and smaller and smaller, all the way to a point 0. We change direction, and our y's become bigger, bigger, bigger. This change in direction is our vertex. Now, depending on whether our vertex is at the bottom of our graph or at the top of our graph, determines whether we have a minimum or a maximum. As you can see, if we put our quadratic in standard form, we can tell quite a lot about the graph of a quadratic equation. We can tell whether that graph opens up, opens down. We can determine if the graph has a minimum or a maximum. We can determine where the vertex is, and we can also determine where the y-intercept is, or where this graph crosses the y-axis. As you can see, this is the graph of y equals x squared. Since we have no c, the c would be equal to 0. And as you can see, we cross our y-axis at 0. And because a, in this case, would be 1, and a is positive, we can also see our graph opens upwards. Okay, practice. Let's see what you know so far. Which equations are quadratics and in standard form? I want you to look at these 5 equations and determine whether it's a quadratic in standard form or if it's not. Feel free to pause and try to do these questions by yourself. Okay, so we know the standard form for our quadratic equation is ax squared plus bx plus c. So we need an x to a second power, we need an x to a first power, and we need some constant. Looking at this first equation, I don't see any x to a second power, so I know it's not in standard form. The second equation, I see the same issue. We don't have an x to a second power, so I know it's not in standard form. Here we have an x to a second power, an x to a first power, and a constant, so this is in standard form. Here again, we have an x to a second power, an x to a first power, and a constant. So this would also be in standard form. Here, we don't have an x to a second power. While we do have 2 x's to the first power and 2 constants, since we're missing our x to the second power, this would not be in standard form. Okay, some more practice. Determine whether each of these equations open up or down. Feel free to pause again and check your answers later on. So as I talked about before, a in our standard form equation determines whether our equation opens up or down. If a is positive, our graph opens up, and if a is negative, our graph opens down. A just represents the constant in front of x squared. So as you can see here, 2 in front of x squared is positive, so our graph is going to open up. For the second one, negative 4 is negative, so our graph is going to open down. And the last one, negative 3 is also negative, so our graph is going to open down. So what are roots and zeros? Roots and zeros refer to the x values crossed in a quadratic function. We can find roots and zeros graphically and algebraically. These are the 2 methods. So if we're going to go ahead and find a 0 graphically, we're going to find where the graph crosses the x-axis. And to find zeros algebraically, we're going to find the x values that make a quadratic equal to 0. So here I pulled up 3 graphs below. If we can see here, we have a 0 for this first graph at 0, 0, because this is where a graph crosses the x-axis. So as you can see, it's very easy to go ahead and find zeros graphically. For this graph, we have a 0 of negative 4, 0, and 1, 0. On this graph, we have a 0 of negative 4, 0, and 2 comma 0. So as you can see, when you go ahead and graph a quadratic equation, finding zeros are very easy. Okay, let's practice finding zeros graphically. For this graph, I want you to find the zeros of the quadratic function. Feel free to pause, find the zeros, and resume when you have your answer. So we know zeros are when the graph crosses the x-axis. So let's identify our x-axis. Our x-axis is right here, this line. So you can see on the left-hand side, we cross this line at -5. So that would be one of our zeros. And on the right-hand side, we cross the x-axis at 1. So that would be another one of our zeros. Those are our two answers. So we can also find zeros using algebra. Every quadratic equation can be solved using these two algebraic methods. So we can either factor and set our x equal to 0, or we can use the quadratic formula. Now I already made a video explaining how to factor and how to use the quadratic formula step by step. You should see that video in the top right of your screen right about now, and I'll also link it in the description below. Okay, let's talk about the discriminant. The discriminant is essentially an equation that allows us to find the amount of zeros a quadratic function has without solving for x. So if we go ahead and put our quadratic equation in standard form, ax squared plus bx plus c, and we plug in these constants into this equation, we can determine the amount of solutions our equation has. If the number we get is greater than 0, we have 2 solutions. If the number we get is less than 0, we have no solutions. And if the number we get is equal to 0, we have 1 solution. And remember, solutions are the same thing as zeros. It's when our graph crosses the x-axis. Okay, let's practice using the discriminant. For these 3 equations, I want you guys to find the discriminant and the number of solutions. Feel free to pause, work it out, and resume when you have your answers. So we know the equation for the discriminant is b squared minus 4ac. In this equation, -2 would be b, 6 would be a, -3 would be c. Writing this out and using the equation, we have -2 squared minus 4 times 6 times -3. -2 squared is 4. Minus 4 times 6 is 24 times -3. Doing our parentheses first, we have 4 minus -72. And we know when we subtract from a negative, that turns into a positive. So this would turn into 4 plus 72. And this would turn into 76. Because 76 is positive, we have 2 solutions. Or 2 zeros. Checking our answer, we got it correct. Okay, number 2. Here we have -4x squared minus 4x plus 5, where -4 is b, -4 is also a, and 5 is c. Writing this out, we have -4 squared minus 4 times -4 times 5. -4 squared is 16 minus 4 times -4 is -16 times 5. Because we do parentheses first, we have 16 minus -16 times 5 is -80. And like the last problem, double negative means addition. 16 plus 80 gives us 96. Because 96 is positive, we have 2 solutions. Checking our answer, we got that right as well. For our last equation, we have 9x squared plus 6x plus 1, where 6 is b, 9 is a, and 1 is c. Plugging this in, we have 6 squared minus 4 times 9 times 1. 6 squared is 36 minus 4 times 9 is 36 and times 1, that would just be itself. So we can literally just cancel that out. 36 minus 36 is 0. And if you remember, 0 means we have one solution. If we check out our answer, we got that right as well. I pulled up a graph of this last one to just show you what one solution would look like. One solution is when the vertex is touching our x-axis right here. So as you can see, for this graphed equation, we would have a solution at the vertex. So you know that if we have a quadratic equation and you do the discriminant and you find we have one solution, you know that our vertex is touching the x-axis, or that our vertex is one of those solutions. So quadratic equations can take different forms. I listed out all the forms a quadratic can take. So number 1, we have where all x's in a quadratic equation can be replaced with any variable. Here's an example. 2u squared minus 3u plus 9. As you can see, x is replaced with u. This is common in word problems where, let's say, we're talking about time, and instead of using x, we use t. X can be replaced with any variable, number, or symbol in a quadratic equation. Number 2, we have quadratics that are split into an equation. Here's an example. We have 5x squared is equal to 3x plus 4. As you can see, just because our quadratic equation is not all on one side of the equal sign does not make it not in a quadratic equation. So yes, you can see quadratics with multiple variables a, b, and c on different sides of an equation. It's still a quadratic. Thirdly, we have quadratics can be shown in factored form where zeros are the x value. Here's an example of that. We have 2x minus 2 times x plus 8. Now if we wanted to get this back into factored form, we would FOIL. That is in the video I'll link to you. It's also in the description. But in this factored form, we can say each one of these parentheses equal to 0, solve for 0, and find our zeros. This is still a quadratic. And lastly, we have quadratics can be shown in terms of the vertex. This is also known as vertex form. And here's an example of an equation in vertex form. Okay, next let's talk about vertex form. Vertex form is still a quadratic equation, but here it's very easy to go ahead and identify the vertex. The vertex is the opposite of this h value and this regular k value. And this will give us the vertex of any equation. Right here we have steps for turning an equation in standard form into vertex form. These steps may seem very complicated, but I will go over the steps in multiple practice problems, and you'll see it's not that bad once you get used to it. So the first thing we want to do is turn any equation we have into standard form. Ax squared plus bx plus c. To do this, you may need to FOIL, or you may need to just distribute factors. Secondly, if a is greater than 1, so if this value is greater than 1, we want to group a and b together and factor out the GCF. Next, we want to complete the square by doing b over 2 and then squaring it. Next, if we did step 2, if we factored out a GCF, we want to multiply this b over 2 squared value by this factored out term. Next, we want to subtract this factored out term from c. Then we want to divide b by 2, add x, and square it. Lastly, we put the factored out coefficient in front of this value found in step 6. Okay, let's practice using vertex form. I want you guys to put these two equations in vertex form. Feel free to try it out. If you get stuck on something, don't worry. I will work it out in just a second. Okay, for this first equation. So the first thing we want to go ahead and do is look at our a value. Because this is already in standard form, we don't have to go ahead and do any type of factoring or FOIL. Because a is equal to 1 and we don't have to factor out anything, we can skip that step. The next thing we want to do is complete the square. To do this, we're going to take our b value, divided by 2, and square it. So negative 4 is our b value, divided by 2, and squaring it. Negative 4 divided by 2 is negative 2, and negative 2 squared is 4. Next, we're going to subtract this from our c value. So negative 21 minus 4 is negative 25. So this is going to be our final c value. So we'll hold on to this for later. Next, we're going to take our b value divided by 2 and add x. So negative 4 divided by 2 is negative 2. Negative 2 plus x gives us x minus 2. Next, we're going to square this value. And then lastly, we're going to put this remaining c at the end. Just like that, our equation is in vertex form. To find our vertex, we do the opposite of this value as our x. This is also called h. We do the opposite of h. This gives us 2. And we keep k the same, which is our y value, comma, negative 25. This would be our vertex. Checking. And we get our vertex form. Okay, next one. Here we have y is equal to 4x squared minus 12x plus 9. As we see, this is in standard form, so we don't have to do any type of foiling. However, a is greater than 1, so we are going to have to take out a GCF. Because a is greater than 1, we need to go ahead and factor out 4 from everything. Unluckily for us, we don't have a GCF of 4. As you can see, 9 doesn't have a factor of 4. So we're just going to have to go ahead and divide our whole equation by 4. So dividing this all by 4, we have y over 4 is equal to x squared minus 3x plus 9 over 4. Next thing we want to do is to go ahead and complete the square. To do this, we have to do b over 2 squared. In this case, b is negative 3 over 2 squared. This is just negative 3 halves squared. And if we do negative 3 halves multiplied by itself, we can square it. Here, we would get 9/4. And this is subtracted from our c value in the next step. As you can see, 9/4 is our c. So 9/4 minus 9/4 is equal to 0. So we do that. We see these 9/4 cancel out. Because our c is now sorted out, all we have to focus on now is dividing b by 2 and adding x to it and squaring it. So negative 3 divided by 2 is negative 3 halves. If we add x to that, we have x minus 3 halves. And if we square this number, we get x minus 3 halves squared. Because we have no c, you can either put plus 0 or do nothing. And we were left with y over 4 is equal to x minus 3 halves squared. Because we don't want to leave this 4 on this left side of the equation with y, I'm going to multiply both sides by 4. Doing so, y is left alone. We get 4 multiplied to the value of x minus 3 halves squared. This is our final vertex form. Checking our answer, and we got it correct. Okay, last set of practice problems. Here, I give you guys 6 equations. I want you guys to determine whether it's in vertex form, standard form, factored form, or split form. Feel free to pause the video, work it out, and unpause when you have your answers. For this first equation, I see we have x to the second power, x to the first, and a constant, so I know this is in standard form. For the second equation, I see we have 2 seemingly factored pairs, and I know if I set each of these equal to 0, I can find my zeros, so I know this is in factored form. For the second one, I see we have x to the second, I see we have x to the first, and I see we have a constant, so I know this is in standard form. For this fourth one, I see we have x to the second, x to the first, and another x to the first with no c value. C can be 0, so I know this could be standard form, but because I see 2 values on each side of the equal sign, I know this is in split form. For our fifth one, I see a combined value to the squared, and I see a constant. Because I know we have an x and a constant squared and an excess value, I know this must be vertex form. And lastly, I see we have two sets of factors, and I know if I set each of these equal to 0, I will get two sets of zeros, so I know this is in factored form. Alright guys, that's the end of the video. If this helped you out at all with quadratics, make sure to like. Also, if you have any questions, feel free to comment them down below so I can answer them. Make sure to check out any of my other videos. Enjoy the rest of your day, guys.